Welcome to this session, which is about surge control line and surge flow adjustment in AspenHYSYS steady state. When we have the compressor curves, the recycle rate for the compression loop needs to be quantified for each case. Surge flow adjuster to be added based on the surge control line. This operating window is for a centrifugal compressor and variable speed type. The line on the left side of the envelope is the surge line. Any operating point, in reality, in practice, on the left side of the surge line can result in a catastrophic damage to the compressor. Surge control line, which typically have 10% margin with the surge line, is introduced to make sure that always we have the operating point over the surge line or slightly on the left side of it or on the right side of the surge control line. This 10% margin is because of the fluctuation during process control. The operating point also should be between the minimum and maximum speed curves in your simulation. In any case, if your operating points are outside of the max speed curve and min speed curve, it indicates your compressor is not suitable for your condition or something is wrong in your simulation. The operating point needs to be also on the left side of the stonewall. So stonewall, surge line, surge control line, and min and max speed of the compressor defines the valid operating window of a centrifugal compressor. If you had a fixed speed centrifugal compressor, we had only one curve. We had a stonewall point and surge point, or surge control point and surge point. You remember we had 6 cases on the previous sessions. If you want to map them based on our compressor curves, you can see clearly one of the cases is on the left side of the surge line and surge control line, so it requires some recycle flow. These 2 points also likely have slight recycle. These 3 points are okay. Here are the curve data. The minimum flow for each speed is corresponding to the surge flow on that speed. So we need all these minimum flows to create the surge line. Here are the data for the surge line. So you see the minimum flow at corresponding speeds. So when you plot them, you will obtain an equation. And based on that equation, you can also have the surge control line and implement it in your simulation to have the surge flow adjustment. Just remember, you need to have enough number of decimal digits for precision. Otherwise, you will have some level of errors. It can be high, it can be small. As I said, 10% margin with the surge line give you the equation for the surge control line. Now we can do exercise in Excel and later in AspenHYSYS simulation to formulate the equation and implement it in the AspenHYSYS. This is our curve data. On the x-axis, I need to have the compressor speeds. And the surge flow at each speed. So now you can plot them. Do a regression. Select polynomial. Second order seems to be fine, but the third order will give you a more accurate equation. You can also see it from the R² values. This default illustration of the equation is not usable. It gives you a high level of error in your calculations. So the best is to go to numbers and use, for example, 15 decimal digits. Now we have the equation and we can implement the surge flow adjuster in the simulation. What I need is the spreadsheet for the calculations and adjust function for iteration process. First, set up the adjust function without the specified target value, which will be calculated in the spreadsheet. My adjusted variable, it can be is for the recycle stream. It can be the molar flow or mass flow. Molar flow is typically easier, and the target variable in the compressor section, actual volumetric flow. Now the target value. In the spreadsheet, I need to calculate the surge flow based on the speed. So I need to bring the compressor speed to the spreadsheet. Drag and drop it there. Now I have also the equation, which is in the style required for AspenHYSYS spreadsheet. Only thing I should do is adding 1.1, multiplying to 1.1 to make it 10% additional. And the unit should be similar to the target variable unit, which is the actual volumetric flow. It should be actual volumetric flow, the variable type. So now we set up the calculation for the surge flow plus 10%. Now the specified target value is from cell B2 of the spreadsheet, and no offset is needed. Parameters, the default value for the target variable tolerance is high in AspenHYSYS and should be changed. So now I put 1. Step size, if you put a small step size, it takes longer to solve. A large step size can make another problems in the solving. So I put a number like 25, which might be still a small step size, but reasonable. Minimum and maximum values for the adjusted variable is optional, but it is better to add that. Otherwise, you will get unreasonable results. For example, you know that there is no pressure driving force from suction side to the discharge side. So having negative flow there or negative rate on that stream is completely wrong. So we should avoid it. So 0 should be an absolute minimum. So set it to 0 for the minimum, and for the maximum, based on the maximum surge flow plus 10% margin at maximum speed and also maximum expected suction pressure, you can find out what is the molar flow respective to that condition. Then you can add it as the maximum with some small margin maybe. So here I expect 15,000 to be a maximum number and a high number of iterations here. Do not ask me frequently to continue the iteration, so less interaction is needed. Now if I start to reduce the flow, we will face issue with solving the adjust function, and I will let you know how to can solve the issue. Here I will reduce the flow and see if the surge flow getting adjusted. No. So it doesn't work. You have to manipulate numbers in the surge flow and change it, or sometimes push reset to be fixed, but most of the time there will be frequent issues like that. So you cannot come back to the adjust function every time and fix it. So the best way to overcome this issue is to go to the solver and change the calculation order. So here it has a similar calculation order to recycle operation. If you increase it with a higher calculation level, then it is less likely to face such an issue. So if I bring my feed value for the molar rate to original number, now again reduce it to 7,000. Let's see what will happen. Now you see by this change in the calculation order, the adjust function working properly. So if I reduce it further, and also I can bring this stream, you see how that flow is adjusted accordingly. Again adjusted. Let's increase it. Yeah, it's close to that number, previous number. So now you see your adjust function is working, and also you find out how you can mitigate the issue you typically face with adjust function. Thank you for attending the video, and have a great time ahead.